In this video, we will write a program to display the readings from the gyro to the telemetry data of the driver station. To do this, we'll need a new Java class in your op modes folder. So I'm going to create a new Java class. I'm going to name it MRI underscore gyro underscore video. The reason I'm naming it video is because we'll use the same program and build on it moving forwards, not just use this one for reading. So this would be throughout these videos. I'm going to say OK. And I've got this here. Now, the first thing to do, because otherwise you'll forget and hit yourself in the head later, is add it to FTC op mode. So here I have gyro video, MRI gyro video.class. I'm going to add that in, otherwise you'll regret it later. MRI gyro video. So here we'll need to take this and extend it to linear op mode. So we'll say extends linear op mode. When I did that, it automatically imported this line. If you type out all of linear op mode, you'll need to type out that import. Next, we're going to have a override, and this will be override. This will be a public void of run op mode. Not public, public. Usually if something's going wrong, it's usually a spelling mistake, at least for me. There we go, fixed it all. Now the first things we're going to do is make some variables. So these variables are going to hold, they're going to hold the readings until we're ready to display them. That way we can get the readings and then do something like move the robot and then also display them to the screen. So we're going to have 5 variables. They're all going to be ints. We're going to have z accumulated, heading. Now we can type these variables out one at a time, or you can also say int xval comma, and these are all the same categories, so I'm going to put those all together. Now we're going to make the instances of the gyros that we need. Unfortunately, we need 2 because the gyro sensor does not have, or the gyro sensor object does not have all of the functions that we need. Now, look again how this imported this import as I typed in gyro sensor. So if yours did not, you'll have to type out that import. The next one is going to be modern robotics I2C gyro. If I had to enter, it should do the same thing. Pow, there it is, modern robotics I2C gyro. And this I'm going to call MR gyro. Now we need to tell the program where this gyro is on our robot. So we're going to say sensor gyro equals hardware map dot gyro sensor dot get. Notice how I named it with all lowercase letters. This makes it really easy to type out on the screen of your smartphone. If you had numbers, or if you had special characters like underscores, it makes it a lot harder. So keep it letters that are lowercase and short. Next, we're going to cast the MR gyro. So we can say MR gyro is a modern robotics I2C gyro that is taking the properties of sensor gyro. Not my gyro, MR gyro. There we go. Oops. There. Next, we're going to calibrate the gyro. So we're going to say MR gyro dot, you can see all these things you can do. We're going to calibrate. And that's going to turn on the blue LED on the gyro sensor. When the blue LED is solid on, it is calibrating. This is figuring out what readings it gets when it's not moving, so it's telling itself what values are normal, and it's also updating the heading and the z integrated value to be 0. So then that is your normal position in the world. Next thing we're going to do is wait for start. So you're going to wait for that big play button you pressed on the driver station. Then we're going to make sure that the gyroscope is done calibrating. Now the gyroscope usually takes between 2 and 3 seconds to calibrate, but instead of putting in a delay or a sleep of 4 seconds, instead of that, we're going to ask the gyroscope, are you calibrated yet? Are you calibrated yet? Are you calibrated yet? Are you calibrated yet? So to do that, we'll say while, and actually instead of sensor gyro, say MR gyro is calibrating. We're going to do nothing. We're just going to sit there and wait. Next is the most important part of your program. Don't delete this loop because this is a loop that's going to go through over and over. While op mode is active, that's where we're going to do the meat and potatoes, the vegetables of the program are going to be all in here. So we're going to start by setting all the variables, these guys, to be the readings from this guy. So start from top bottom, we'll say z accumulated equals mr gyro dot get integrated z value. And then we'll say heading is mr gyro dot get heading. And then we'll say the xval is mr gyro dot raw x, y val equals mr gyro dot raw y. Look at how smart this programming language is. Z val equals mr gyro dot raw z. That's it. So that updates all of our variables to match what's coming out of the gyroscope. Next, we're going to display this to our robot controller. We're going to add data. I really like what FTC does as putting, or the examples, as putting in numbers, because then it'll show up in the order that you put the numbers in. So I'm going to say one is heading. And all you need to know about this string format is it's taking off all the decimal points of heading. So instead of displaying 0.00 after the number, it'll just display the whole value. That makes sense because the gyro is only just feeding back a whole value anyway. Accumulated value, the accumulated. X. We have X, which is going to be xval. I'm going to copy that guy 3 times because I'll make it easier to just change this one thing here. Xval, yval, and zval. One more thing, and that is to wait one full hardware cycle. Now, to make sure all of our code looks clean, we can go up here and say code, reformat code, and we'll say run, and that's going to make sure that all this stuff lines up neatly. If we didn't have a space after the equal sign, it would put that space in. That's it. We will now download this to the phone. I have it downloaded here, and I'm going to connect it to a gyro sensor. So here I have a gyro connected to my core device interface, which is called gyro in the configuration file. And I'm going to start my gyro video program. I'll say init. The gyro is solid blue. Now it's back to flashing. I'm gonna press the play button and it'll display all the values there. Now you can see that as I rotate this, the heading and the Z change. So if I rotate it 90 degrees, you can see that it displays 90 degrees. We're back to 0 or to 70. The Z accumulated goes positive as you rotate to the left. Unfortunately, through the FTC SDK, the heading goes positive as you rotate to the right. Now you can change that. Also, the rate rotations, X, Y, and Z, have a lot of noise on the end of them. And now this is built in on purpose. There's a lot of noise on them. It is necessary for the integration. But for our purposes, you may not want that. We can change that. So over here, I'm going to say the X val equals raw X divided by 128 divided by 128 divided by 128. So that will get rid of that noise. Other thing you can do, if you want the heading to be positive and negative the same way that the integrated value is, you can take the negative of it, but then you also have to add 360. And then another thing they have to do is actually, if heading equals 360, then heading equals 0. Because of the way that math works out. So those are a couple ways that you can make that a little bit better. Again, I'm going to say code, reformat, and it made all this look nice and pretty. So that is how we can display your gyro values to your telemetry data on the driver station.